Hi everyone, I'm Shubham. I'm here representing as AWS Ambassador, and today we have a special guest with us. Please welcome Carl. He's from Norway. He is a working professional and AWS certified solution architect. Today he'll be introducing you all to cloud computing and discuss some of the AWS services with us. If you have any questions, please do ask in chat section. Now I'll hand over to Carl. Yeah, Carl is here, and I'm handing over this to Carl.
Hi, thank you. Let me do this first. One second. I just share the right screen first. There we go. All right. Thank you, and thank you for this invitation and an opportunity. Like I said, my name is Carl. I am a I'm currently working full time as a cloud consultant and cloud architect in Norway. I'm also one of the AWS Educate Cloud ambassadors, representing a university college in Norway. I'm 30 years old. I will soon have two kids. Have one already. I am a developer. I'm a photographer. I'm an architect, and I'm a lover and ambassador of DevOps and the DevOps philosophy. I'm here to give you all a brief introduction to what is cloud computing and why you should consider cloud computing. This is meant as an introductory course, just a brief introduction to give you a glimpse into what you can be reading and studying on your own, and what will be covered for a bit during these next couple days. But we're going to begin by talking about why you should consider cloud computing and what cloud computing is. I can tell you this much because I found this on Twitter just a couple of weeks ago. This is not cloud computing. Cloud computing isn't just the files are in a cloud somewhere, but the photo is pretty good. There is a saying that's been said in the IT industry for quite some time that there is no cloud, it's just someone else's computer. And that's the truth, because although you might not have a physical server anymore, you might have stored in what's known as the cloud. This is just someone else's computer. It might be owned by Amazon, it might be owned by Google, Microsoft, or any number of other cloud or virtual server providers. It is just someone else's computer. So it isn't magic. But we're going to need to try and consider what cloud computing is and where we came from. If we go back to the early 90s, and for many, most of the early 2000s, we had what was known as a traditional server farm. You had a bunch of different physical servers in a closet somewhere or in a server room if you were lucky. You had one server, physical box per service. So if you had if you had a website running and a database, you typically had one physical server for the database and one for the web front end. If you had an HR application, all kinds of things, you had one physical server per service. In many cases, you had for web services where you needed to scale, you needed multiple physical servers to scale this. Although, yeah, this works, it's super inefficient. It takes up a lot of space, a lot of energy. It costs a lot, and the lead time for getting a new server is very long. If you, as a company, let's say you build an application from scratch, you launch it on your physical servers, and you realize, and your application explodes. It becomes super popular. it would take you weeks or months to be able to scale up to the level of demand that the application needed for most part, unless you were very good at predicting how well your service was going to do. That's because it took time to order the servers from the manufacturer. It took time to get the server racked in a rack, connected to wires, installing an operating system. All these kinds of things took a long time. And for most of the time, these servers were super inefficient because you had a lot of power, but you weren't necessarily running at 100% of the utilization all the time, meaning that you had a lot of wasted time and server capacity. So what ended up happening is that we moved in the late 90s, early 2000s, a lot of companies moved to what was known as virtualization. The new shiny thing. You had, instead of having a bunch of different servers, physical boxes, you had fewer physical boxes, but these boxes often had a lot more horsepower. We had special applications allowing you to run multiple operating systems on one physical box. This greatly increased our utilization of the servers. It allows us to run at close to 80 or 90% utilization at a lot of the time using virtual machines, which is great. It also somewhat sped up delivery because it allowed you to run multiple services on one physical box. You can now run both the database and the web front end on one box, and that's great. The problem again becomes, though, what happens when your physical box runs out of capacity? What happens when you run out of RAM or CPU or disk? Well, again, you need to order new physical boxes and rack them, stack them, install operating systems, all kinds of things. This also moved, or significantly rather, increased the cost of entry. The barrier to entry for virtualization is very high because you need you need servers with very good specifications. You need a lot of RAM, you need a lot of CPU, you need a lot of disk, meaning it's going to cost you quite a bit to get to that point. So the barrier to entry for a lot of small businesses was very high, and a lot of small businesses have struggled to deploy virtualization. But in in the late 90s, it wasn't a thing, but until it was pioneered by Salesforce, what was known as, or became known as cloud computing. AWS launched in 2002, and and we're moving to the cloud. AWS launched in 2002, and it allowed you to rent server space, and it allowed you to scale basically unlimited. You could add new services and scale your infrastructure up and down or horizontally by adding new boxes almost instantaneously. There are no upfront costs of this. For most things, you pay as you go. The deployment of new services are almost instantaneously, and for many of the things we're doing today, we have what's known as managed services, meaning that you no longer have to maintain the operating system for the service. If you're running an SQL database, you no longer need to maintain the underlying operating system because that's taken care of by the cloud provider. For those applications that you still need an operating system and you want to maintain that, that's still available. You can still get a box, say that, okay, this is a virtual machine in the cloud, no problem. But again, it's much, the barrier to entry is much lower at this because there's no upfront cost. And again, it scales basically unlimited. It also has quite a bit higher security than your traditional infrastructure. I know a lot of IT people like to say that, no, my servers that I have physically in my data center are much safer, and the data is much better protected than the data that is in the cloud. And honestly, that's simply not true. You're fooling yourself if you think that you as a sole or just a part of a 2 or 3 person IT team have better security knowledge than the hundreds of security experts that work at AWS or Azure or Google Cloud. These guys have developed a system that is very, very secure, and that unless you go in and configure this in a way that you're not supposed to, and configure this system to be insecure, the cloud is a much more secure storage for your data than the physical on-prem servers that you had in the past. However, there's a downside to this. Although the upfront costs of physical server or cloud is cheaper than on-prem servers, over time, if you're just taking one server and lifting it to the cloud, so copying everything up, it becomes really expensive really quickly because the resources are expensive in the cloud. There's no doubt about it. This means that in most cases, if you're moving to the cloud, you need to reconsider your applications. You need to reconsider what you're doing, and you might need to refactor and re-architect your application to work well in the cloud, to not ruin you. There is a strategy known as lift and shift, and that's just basically copying everything up to the cloud as is, and that's a very, very poor strategy for most users. But the cloud, in every other way, gives you a lot of things. It gives you flexibility because it scales up and down and horizontally. You can add more CPU, you can add more RAM, you can add more disks to a physical server if you want, or you can add more servers and load balance between the servers. You can choose different storage options. If you have data that's not very often or frequently accessed, you can choose a hard drive instead of an SSD. If you have a database that needs to run, you can run it off of provisioned SSD with a very, very high IOPS for your needs. There's a ton of security features in the cloud, so as well. So it secures your data. It's more efficient. It's more accessible. It's available to everyone, everywhere. When you're in the cloud, there's no need, if you don't want to create a bunch of VPN clients and these kinds of things. You can access the services anywhere in a very short amount of time, and it allows you to speed up your delivery to market. When you're launching a new application, you can click a couple buttons in AWS and deploy it instantly to hundreds of servers. This isn't possible in most cases with virtualization or on-prem servers. You can't deploy as quickly. You save the upfront costs again. If you architect this properly, you can save money by moving to the cloud. However, for most people, you're trading upfront costs to capital expenses, so running costs. There's also strategic value. Moving to the cloud and using managed services such as managed databases, managed servers, and all the other things that are available. You can run an Active Directory in the cloud and not have to worry about Active Directory ever again. All these kinds of managed services allow you as a company to focus on the application development, not the infrastructure. You can run regular updates. You have global distribution if you want. You can deploy an application across the world in minutes using the cloud. However, there are a couple things we need to know about when we're talking about cloud computing, because there's different types of cloud computing. Or different levels, rather. We have what's known as IaaS, or more commonly known as infrastructure as a service. This is basically a virtual machine in the cloud. IaaS gives you, as a company or systems administrator or developer, just a pure virtual machine in the cloud, and you can do whatever you want with it. It's super easy. It's provided by all the big cloud infrastructure providers, and it's an easy way to get started. However, if you don't want to focus on infrastructure, you have what's known as platform as a service. Sorry. You have platform as a service. Here, you're focusing on the code and not on the server or operating system or storage. You have tools such as AWS's Elastic Beanstalk. Google has its App Engine, which is super popular, allowing you to deploy applications and monitor applications in minutes. It's a very cool thing, and you should consider looking into it because, again, it's very cool. Red Hat has its OpenShift, but again, it's a platform as a service. You no longer have to worry about the operating system. It's run for you. The next thing is software as a service. This is more commonly known as basically just applications that are available to you. Typical examples are Office 365, G Suite, Gmail. Salesforce has their software as a service capability. Adobe's Creative Cloud as a software as a service. SurveyMonkey, Slack, all these kinds of applications where you don't worry about anything. You just get an application and no longer have to think about it. You just use the application. On top of that, there are tons of other as a service types of things. Just name it as a service, backup as a service, networking as a service, containers as a service, desktops as a service, or whatever you want to name it, pizza as a service, why not? All right. I'm going to step back a bit, and we're going to talk about deployment, because not every business is ready to move everything to their cloud yet. A lot of businesses are still what's known as on-prem, or in many cases, they're not necessarily on-prem, where everything is only available in their infrastructure, but it's available using a VPN or something like that. But everything is hosted out of your own data center. This is known as what's called a private cloud. This is mostly old stuff. More and more companies are moving to what's known as a hybrid cloud. This is an intermediary step where you have a bunch of applications on-prem, but you're also utilizing the power of the cloud to deploy new applications or moving applications to the cloud. In this case, many applications can actually be run still in your data center and have a front end or cache in the cloud, or you can have, again, just some applications in the cloud and some in the old infrastructure. It's a mix of both worlds, and it can speed up applications that are needed, that are heavy applications needed on-prem. Some 3D applications, for example, 3D drawings, a lot of these can benefit from having the application on-prem and having files locally where the employees are actually working, so you don't have to think about transferring 10 or 15 or 30 gigabyte files back and forth to the cloud every time you want to do this. Doing a hybrid cloud can benefit you as it significantly speeds up deployments because you can, again, utilize the cloud to deploy new applications. But it allows you to do a longer migration period from moving to the cloud and not do everything instantaneously. However, the downside is that it can be slow for some of the applications, and it can be expensive because you need to maintain two kinds of things. The final kind of deployment is public cloud. This is what most people think about when they think about cloud. This is where everything is basically run in some cloud somewhere. It's perfect for startups or companies that have little or no technical debt, meaning that they have no on-prem application that they need to worry about. The public cloud, you benefit from everything we've been talking about so far: elasticity and instant deployment and speed, and again, no upfront costs. But this is when you're running everything off the cloud. All right, we're going to move on to the main topic of this, which is just Amazon Web Services. Amazon Web Services is the largest cloud provider today, closely followed by Azure and Google Cloud. There are tons of other cloud providers still. The largest ones are Alibaba Cloud and IBM. DigitalOcean, Oracle has some, Rackspace, and tons of others. But Amazon is the largest with about 32.5% of market share in Q4 2019. For comparison, again, Amazon has 32%, Azure has 17%, and Google has 6%. This means that Google and Azure combined has 23% market share. So Amazon is about 10% larger than Google and Microsoft combined. If you combine Alibaba as well, which is the number 4, you're still only at 29. So Amazon is by far the largest. And if you're looking into doing certifications, for example, the Amazon ones are worth their weight in gold. Like I said, I'm certified as a solutions architect. There are tons of other application or certifications. You have the certified developer, which I'm currently about to take next week. You have big data specialists, you have AI specialists, and all kinds of things you should consider looking into. And they're for employers, they're very valuable. AWS consists of a bunch of data centers. They're located physically around the world in different locations. You can see them on the map here where they're currently at per the 30th of May. Each physical location around the world is known as a region, and this region consists of multiple data centers. So if you look for my neck of the woods, so in Scandinavia, in the northern Europe, there's one circle up in Sweden. That's known as the Sweden region. That region consists of 3 or more data centers that are known as availability centers, or availability zones. My apologies. Each physical data center or availability zone are physically independent of each other, and they have redundant internet and power, meaning that they could lose power from one provider and still be up with no issues. They also do the same for internet. And all the data centers in a region are interconnected with very high-speed internet. They have multiple high-speed gigabit connections, so that the latency between data centers are very, 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 very low. Each data center is built in such a way that in case of a natural disaster, you shouldn't be able to take out more than one data center at a time. So in case one goes down, the others should still work. They're all separated by multiple kilometers, but they're all within 100 kilometers of each other. Doing it this way allows for what's known as high availability, meaning that you can deploy your application in multiple availability zones. It could go down in one of them, and your application would still work because it will fail over to the other working one. As of right now, they have 24 regions around the world. There are 3 more on the way in Japan and in Asia, as well as Spain. There are a bunch of availability zones as well being added. There are at least 3 per of these new regions. In addition to this, they're not shown on the map, but in addition to this, Amazon has deployed what's known as the edge locations, which are more data centers, but used only for caching. This is for the CDN networks that they have, allowing you to cache things around the world. We're talking 200 plus CDNs around the world, allowing you to speed up delivery for customers in different regions. So you don't have to host all your data in one region, for example, in the US. And if someone from Asia tries to reach it, they don't have to call all the way back to the US and back to Asia to load the data. They can load it from their own local edge site. Okay. That's a bit about the regions. I'm gonna briefly touch on some of the most well-known AWS services, because there are a couple, or there's quite a few. We have EC2 on the left, that's S3 on the right. There's Lambda. You have Elasticache, and a bunch more. The per 2020 or early May 2020, there's about 212 different services in AWS with different names. I will admit I'm not a huge fan of their naming convention. It can be a bit confusing at times. There are a bunch of different names. They don't always make sense, except for some of the larger and most well-known services. So I'm going to, again, briefly touch upon a couple of them. The most common one, and I think the one that most people know about, or at least have used ever, is what's known as Amazon S3. There's never been an Amazon S1 or S2. S3 stands for Simple Storage Service. It's what's known as object storage. This means that you can put photos, you can put text documents, you can put any executable or any file in general in S3. It's unlimited storage. It's truly unlimited storage. You can upload as much as you want, and you will never run out of space. You'll pay a lot for it, but you'll never run out of space. I had a chat with one of the Amazon executives a while back during a conference, and the guy said that, yeah, you could, if you want, and you can do this, you can fill up a truck with hard drives, drive to an Amazon data center, and with an appointment granted, drive to the data center and deliver the hard drives to them and say, put all this in S3. And they will always be able to accommodate this. You can have multiple trucks doing this, and they will always have space, because they, as he said, they have a back door where they can get more hard drives in faster than you can get hard drives to them. Then they guarantee it. So you have truly unlimited storage. There is a limit on each file. Each file cannot be larger than 5 terabytes, but for most people, this isn't a problem. You have what's known as 11 nines of durability. This means that the chances of you losing any data is extremely slim. As soon as you upload data to S3, the data is replicated across the different data centers or availability zones, meaning that the data it's not going to be lost in most cases. If you want to increase the durability, you can also enable replication across regions, meaning that your data is replicated from, for example, from Europe to the US and to Asia and Australia, if you want to. The files are stored in what's known as buckets. The buckets are flat file storage. They don't have a concept of folders in general. They're all stored on the same level. However, you can, for yourself, add folders or what looks like folders in S3 to classify the data and make it easier for yourself. You have 3 storage classes to make it cheaper for yourself. You have standard storage. You have what's known as infrequent access for data that isn't very infrequently accessed. It's cheaper storage, but in some cases you might lose some availability or speed. And you also have one class of storage that's known as Glacier, which is a topic in of itself. However, the bottom line is that Glacier is archival storage. In that case, your data is stored on tapes and in a tape library. It's super cheap. I've stored, I can't even remember. We stored multiple terabytes. We 20, 30, 40, 50 terabytes of data in Glacier, and we paid almost nothing for it. We paid less than $100 per month for it. However, it was only backup data and was only meant to be used in case of disaster and our main data center went down. Because the access time, so the time it takes from you when you click I need this file to when you actually can download it, is measured in tens of minutes, if not hours. S3 also allows you to do simple website hosting. If you have a static website, meaning that you have no website code that needs to run except HTML or CSS or JavaScript, you can host it in S3, no problem. And it's, again, a super cheap storage, if super cheap for that if you want to. So that's the main storage service that I guarantee you, if you're working with Amazon, you're going to work with S3 in some form. The next service that I'm going to touch on briefly is EC2. Again, there's not been an EC1. This EC2 stands for Elastic Compute Cloud, but this is virtual machines. Again, if you're working with AWS, chances are very high that you're going to use EC2 in some form. But these are virtual machines that are physically placed in one availability zone or one data center. When you launch a virtual machine, it's running in one data center. You can access it using SSH if you're using Linux. You can launch Windows Server if you want and access it using a remote desktop. And it acts like any other virtual machine you've ever used, or any remote machine you've ever used. You can scale these servers. You can scale them up and add more CPU, RAM, disk space, all kinds of things if you want. Or you can add more machines and use what's known as the Elastic Load Balancer and load balance traffic between the servers. You have different pricing models. The one, if you're labbing or if you're testing out things, the one you want to use is what's known as on-demand instances. Although it's one of the more expensive ones, or it's the most expensive except for one thing we're not going to touch much on. It's the one where you can click create instance. You can use it for 10 minutes, and you'll only be billed for those 10 minutes that you're using it. There's no extra upfront charges. There's nothing. It costs you're paying per second. In fact, they're measuring you per second how long you're going to use it, and that's it. You're not going to pay for anything else. If you're running this in a production environment, you're most likely going to use the pricing model that's known as reserved instances. This is where you do pay an upfront cost. You say, okay, I am going to sign a contract with Amazon saying that I'm willing to reserve a machine for 1 or 3 years, but that gives you up to 75% off the on-demand pricing. If you're running in a production, this is what's recommended. It saves you a lot of money really quickly. So it's a good alternative. But if you're labbing, testing things out, if you're doing test environments, stuff like that, you want to do on-demand instances because they're so flexible. You also have spot instances. I'm not going to touch on it. It's where you bid on things. Do a bit of research, you'll see what it is. It's super simple, but it's for specific use cases. And you also have, if you need dedicated servers, these are actually dedicated servers. It's not no longer virtualized in the same way. You have your own server. It's very expensive, but it's for customers that have applications that have a license that do not allow you to share hardware with other customers. Again, not very common. I've worked with AWS for quite a few years. I've never seen a customer need it so far, but from the examples that Amazon used, they use Oracle licenses, for example, where you are not allowed to virtualize the Oracle server. You can make the servers private or publicly available, meaning that you can lock them down, saying that this instance is not going to be available to the internet, just for yourself, either using VPNs or network access lists, blocking any other IP. So again, it's very flexible. It's the one bottom or software that you're most likely going to use a lot of. I'm also briefly going to use Amazon Aurora as an example. However, there are many alternatives to this. Amazon Aurora is a managed database, and it's a managed relational database with MySQL and Postgres compatibility, meaning that if you have an application that runs using SQL today, it can run fine using Aurora. However, Aurora is a managed service. You don't have to run any servers or manage how the servers run. You just connect to the instance, and you have whatever you need. It's built in such a way that it's much faster than MySQL. It's much faster than Postgres, and it has the ability to add a bunch of read replicas to increase capacity, and it allows you. It by default replicates and puts up fault recovery across 3 different availability zones, meaning that if one server were to go down, you're not going to lose your data. This isn't really available in most other databases. Microsoft SQL, MySQL to some degree, all these do not have that disaster recovery available. And it's fully managed. There are a bunch of different database alternatives in Amazon Web Services. Again, you can almost, if you can think of it, they probably have it. Oracle or Microsoft SQL, they're still available, but Aurora is the newer version of MySQL that is a very, very good alternative for most people. The final thing is, again, something that is very popular, and especially when you're starting to develop cloud native applications, meaning that applications that are built for the cloud from the ground up. AWS Lambda is something that's really cool. For most other services, you have a physical server that's running somewhere in the background. AWS Lambda, although that there technically is a server running somewhere, you don't have to worry about anything. You write a function or code in general that you can run without having to provision or manage servers at all. You only pay for the time that it takes to compute the function you execute, meaning that if it takes you half a second or 10 milliseconds to run that function, you only pay for those 10 milliseconds. You're not paying for the downtime between each function call. It supports Java, Go, PowerShell, even Python, Node, C#, and Ruby. It's very powerful. It's very cool. And when you're starting looking into cloud native things, this is where you want to go at some point. It's very, very cool. Okay, so we're going to touch on the AWS Free Tier. So the AWS Free Tier, or what's in it for me. A lot of you guys, if you have never created an AWS account, if you go to aws.amazon.com and create an account, you will have 1 year of what's known as the free tier. The free tier gives you a lot of things for free for 1 year. It allows you to run servers in EC2. It allows you to have storage in S3. It allows you to run applications in Beanstalk, OpsWorks, or to use auto-scaling and many, many more applications in the free tier for free for a year. There are 2 tiers of free tier. There's what's known as the always free, and there's the free tier. The key point to know here is that there are some services are always free forever, but some are only available for a year. For example, Amazon EC2. So if you want to run a virtual machine, gives you 750 hours of EC2 compute time per month for free for 1 year. This allows you to run what's known as the T2 micro. So it's one of the smaller instances. It has 1 gig of RAM, I think, or 2 gigs of RAM. Doesn't matter really much, but it's 750 hours per month. This is equivalent to you running one server 24/7 for an entire month, and it's not going to cost you anything. But again, it's counted in hours, so it's up to you how you want to distribute this. If you want one server running for 24/7, no problem. You can do that. Or you could do 10 instances for 75 hours total. So it's up to you. The same goes for the database. For RDS, it's not Aurora, but it's the MySQL equivalent. That's not the Amazon Aurora. Again, look into it, and it's probably going to be covered at some point with the differences here. But Amazon RDS, it's the micro instance, and it allows you to run it for an entire month, no cost to you for the first year. You can store 5 gigabytes in S3 per month for free, and you can do 1 million Lambda requests per month. They count every single request you do against Lambda, so yeah, you have up to 1 million requests per month. These are just some of the services that are free. There are about, I can't remember how many I looked it up, but there are for almost every single service that Amazon provides, they have 1 year where you get free credits to it. In addition to that, if you sign up for AWS Educate, you can complete some basic courses in AWS Educate, and you can get up to $100 worth of AWS credits as well. There are multiple ways you can earn AWS credits, both through Educate and through other services that allows you to do to run things in AWS without costing you anything, and it's a great way to learn. So if you want to try out some of these features, just go to aws.amazon.com and sign up for an account. Again, if you're keeping within the free tier, it's not going to cost you anything for the first year, and it's well worth trying out. So that's about it. I'm not sure if we have any questions. Let me see if I can pull it up again. I lost the chat here for a second. Let's see. There we go.
You all can ask any questions if you have any, so that you can you can add it in the chat section.
Yes, I got it now. So if you have any questions, feel free to ask. Yes, there are multiple availability zones within each region. Let me jump to this. So within each of these blue dots, there are multiple AZs. In most cases, there should be 3. As far as I know, I think the design goal is to at least 3 AZs within each region, but I think the technical specification says that it could be just 2. But again, for most of these, it is 3 AZs at least. US East 1, so it's on the East Coast. US East 1 is the largest AWS region. It has 5 or 6 AZs, and that's the region where most new features get launched first. So if they're trying out a new feature, it's usually available in US East 1 first before rolling out to the rest of the regions. It tends to go US East 1, then US West 1, which is Ireland, before the rest. So
Thanks a lot, man. Thanks, Carl, for this great session. And actually, if people will have some question, they will share with me in this chat. Okay, you all can share with me. Next thing that this was the day 1. Actually, this was the introduction to what is cloud computing, right? So that you all can understand the before diving into the AWS cloud. And I think Carl has done a great job. And so what we are going to do next is we are going to cover every topic that Carl has discussed. We are going to cover most of the services like EC2, S3, and Lambda functions. In fact, we'll cover some machine learning topics like Poly and some AWS Tech Stack and more of them in our coming sessions. So let me show you my screen and share with you something. Just a second. Carl was talking about data centers. This is the data racks that are present in the data centers. And let me show you. This is the small picture that I got from internet. This is the data center at US East 1, North Virginia data center, right? So quite small, right? Next, Carl was talking about AWS certification. You can find all the details on AWS training/certification on this website. I'll share the link with you all in the chat session. This is the AWS Educate, where all the participants have to sign up so that we can have because after this, most of our the webinar will be based on lab work, okay? So that you can practice along with me, or you can practice after watching the video. So we'll share you the link for sign up to AWS Educate account, and please log in using that link. Sign up using that link. You'll get $100 credit if your institute is registered on AWS. If it is not, then please do contact us. You can contact us via email, or you can contact us on LinkedIn directly, so that we can share. Means we can update your institute with the help of AWS members on the list, institute list on AWS. Okay. This is the dashboard of AWS Management Console that you all will see when you will register on AWS. And from tomorrow onwards, we are going to have most of the session based on it. Some of the services that Carl was talking about, like EC2. So here you can see that we have EC2 instance, we have Elastic Beanstalk, we have S3 and DynamoDB, and lot more services are there. Means there are tons of services. Carl has touched most of them, and we will also have the practical implementation of it. Some of them like Lambda functions, Elastic Beanstalk, EC2, and S3, RDS, DynamoDB, and IAM. Uh, my main motive for this webinar was so that I can prepare some of you guys for Cloud Practitioner Examination Certification exam, and that is the fundamental exam for AWS. After this session, I think you all will be able to at least read yourself about the different the services of AWS and topics that is asked in AWS certification exam. Okay. Yeah, this was AWS Poly. While I was reading today, I found this service, and it's really I enjoyed this service. You can just put the text here. It is actually a text-to-speech engine that to Google text-to-speech what we have here in Amazon Poly. Okay, what you have to do, just write your text here, and you can listen to the speech what it is. You can use it in your applications, and I'll show you one of the apps that I have built using this. I think on the last day. So this was all, guys. You all can ask any question if you have. Yeah, we'll be learning all of this in the future slides. That is tomorrow, day after tomorrow, and on 5th, right? We'll have 3 more days conference, and in that we'll have our lab work. Most of the webinar will be based on lab. So thank you, guys. We'll share the link with you to register on AWS Educate. Please do follow that link. Thank you. Carl, you have to say anything?
No, thank you again for the invitation. If you guys have any questions, feel free to reach out. I'm available on Twitter, or feel free to add me on LinkedIn as well. But yeah, thank you for today.